Hi, this is Eric. I'm going to show a quick demo of how someone at Hedron Hackerspace would use Vectric Aspire or VCarve to send a file to our CNC router. First, I'm going to start by creating a new file. I'm going to say that I have already gone and measured my wood that I'm going to be cutting, and it's 4 foot square. And then I took calipers and checked the exact thickness because that's important because you get a 1/2 inch board and it actually often will come out to be something bigger or smaller. So I checked it and it was 45, let's say. I'm going to be working in inches. Uh, if you switch to millimeters, you just have to make sure you send the file as a millimeters file in the end, and I'll go over that. But you can ignore these. This origin position, this is kind of standard, what I recommend people use, because this is where the terminal is that you operate the machine, so that you have the best eye right here. So just leave that there. And kind of first thing you want to do is hit this little sidebar and just pin that, because we're going to be using that the whole time. Usually people have a drawing file, so I'm going to start by importing one, just as an example. Okay, so this has some interesting things going on. So let's say I want to cut this big gear out, but then I want right here, I just want little recesses maybe to hold things, or for here, maybe I want a recess for a bearing, but I don't want it to go all the way through. So that'll be what's called a pocket, and this will be what's called a profile on the outside. So let's do that. So I'm going to click the things that I want profiled. Let's just say I want all of that profiled. And I'm going to come right here, do create profile toolpath, and I'm going to select a tool. Let's start with a 1/4 inch end mill. You're pretty much always going to use a 1/4 inch or an 1/8 inch end mill. 1/4 inch is fast and you can do big materials easily, but 1/8 inch gives you more precision. So it just depends. We're going to see what 1/4 inch looks like and see if we can get away with it. Quite often this stuff is already set pretty well, but let's just go over past steps. General safe rule of thumb for pass steps and step over is to be half of the diameter of your tool, so the radius. So 0.125 would be half. So that's pretty close. So we're gonna go with that. That's just if you do that, you're unlikely to fail because of that. So we'll just stick with that. And I'm just gonna leave these. And then quite often when I'm running the machine, I'm dialing the speed in to get it as fast as I can go, really. So that's selected. The start depth is going to be 0. That's the top of the surface of the material. We're going to define that in real space, and then the cut depth. So this is a 1/2 inch board. So I'm going to say 0.5. Now remember, I set the thickness back in the job dimensions to 0.45. So that means we're going to be 0.05 into the table past our material. So that's good. We want to cut into the material or into the table a little bit just to make sure we get a good clean bottom cut. So this is pretty self-explanatory right here. Outside, we're going to be cutting the outside of this gear because we want to retain the shape of the gear. But yeah, you can tell it to do inside or on those lines that we imported. So I'm gonna leave that. Tabs, I'm definitely going to need tabs. These you can usually leave. And in the newer version, which we have on the shop computer, there's some options that make this easier. I'm just going to hit add tabs and see what happens. So it only gave me 4, so I probably need a little more than that. Max number, distance. Maybe I need to lower the distance. Let's see what happens. Max 8. Huh. Okay. So yeah, so there's some more tabs. Let's say that's fine. If it wasn't, you just click it, click one, and then you can click somewhere else and it moves it. Leads, ramps. You can mess with these and you can get some better surface finishes sometimes, but I'm just not gonna go over that right now. And this is just warning you, you can hit OK because it's just telling you what we already know, that it's going to cut into the machine bed, which we know. And so I'll hit calculate. Oh wait, huh? Okay, so there's an issue with my file. So actually this is kind of a good thing that it came up. So we're going to do edit, select all duplicate vectors. Okay, so there's no duplicates, that's good. And then we're also going to select open vectors. Okay, no open vectors. So it sounds like everything's welded and, man, it's a little weird. What happens if I join? Yeah, it's already joined. So, okay. So, yeah, if your thing has problems, then you can hit those things I just did and often it'll fix them. Let's see why. Yeah, I'm not sure why it failed. Let's try this again. See what happens. Oh. Okay. What's happening is this is too complicated. All right. Let's cut this out. Let's just start over. So now everything should be kosher. Cool. So yeah, to move things around, you click on it once and then click again to bring up the helpers. So we're going to stick with just the little gear because it was crashing because this particular gear I have has way too much detail. So this is fine. We'll just do this. So I'm going to go back to profile, select the 1/4" tool, cutting on the outside. We're going to add tabs. I'm going to generate them automatically. Oh, that's too many tabs. Let's do 4 tabs. Great. Calculate that. And, okay, so it threw us in the 3D view up here. So now if we look, this is going to be able to simulate our cuts. So, oh wait. I messed up. Okay, so I didn't set that to 1/2 inch. 1/2 inch. Great. Cool. Okay, so now we look. So it's going to go in, it's going to cut, and it's going to do another layer. So it looks like 4 or 5 layers here. 4 or 5 passes. And so if I click over here to preview all tool paths, I'll go ahead and move it around. Here, let me change the color so we can see it a little better. And there it is. So that's what we're going to end up with. And we can look in these corners here and let's compare what it should look like. So it is pretty round. Okay, so say we did say we did have a shape that had some really sharp edges. Let's see what happens with this. We'll reset the preview first, and then we'll preview all. And so if we look here, it tried to cut this square. You can see if I unhide our tool path over here, it moved all the way to the corner, but the radius of the tool couldn't cut all the way in. So you end up with a radius right here. That's the diameter of your tool. So if you wanted that to be tighter, you could use an 1/8 inch or a tighter end mill and get that to be a tighter corner, but then it would take more passes because you couldn't go as quickly. And then looking back at this too, we can see, so these dotted line, or this marked line here, is where it will do the actual cutting, and you see it's on the outside of this line and on the inside of this line here, or outside basically. So it alternated. It knew that we wanted this hole to look like that in the middle, so it alternated automatically. Okay, so let's say that we want this to be a recess. So we'll make that what's called a pocket. So first I'm going to take it out of this. So we're just going to do that outer one here. Yes, happy. And then I'm going to close this preview window. I'm going to go back into here and we're going to create a pocket. I have to click back into this tab. I'm just going to click this, and let's say it's only going to be 1/4 inch deep, so 0.25. I'm using a 1/4 inch end mill, everything's kosher. So you can see, did some fun stuff there. We're going to preview all tool paths. So it went and cut profile 1, and then it cut the pocket. In reality, I would probably want it to do it in the other order. So I'm going to actually hit this little button here. So now it'll cut that pocket first while it's still really rigid, and then it'll cut the gear out, and that'll kind of make it flimsy, which is a little better to do later. So okay, so there's my thing. I'm ready to send it. Simulated everything simulated okay. We're gonna see what happens at the machine in the real world, and so let's turn these on, and we're going to make sure right here it's set to EMC2 arcs, and then I was using inches, so we're going to stay in inches in good old freedom units, and then we're going to hit save toolpaths. And then you'll put this NGC file on a flash drive. It has to be with an older FAT formatting. So we have a few that we usually just use for the CNC, but you'll save this file onto a flash drive and bring it over there, and that's it for this.